we're ready to move on to Chapter 5. And in Chapter 5, we're going to look at ways to design surveys, experiments, and look at some simulation of data. And the first thing we need to do is look at the difference between what a population is versus a sample. And if we can talk to the entire population, then we're doing a census. So if we're collecting data for every member of a population, then we are conducting a census, and we have all the information. We would calculate, possibly if it was something numerical, we could calculate a mean that is actually a mu. Remember, this symbol is the population mean. We could calculate the population standard deviation if, again, we had numerical data. On the other hand, if we're taking a selection of the population, then we would have a sample. And if we had numerical data, we'd be calculating the mean as an x bar and the standard deviation as an s. Now, we have to be very careful about the way we collect data because almost always for our data collection we're using a sample. We very rarely are looking at the entire population, and we have to be careful about having bias in our selection of our sample. And any type of bias is where we systematically favor certain outcomes over another. One large type of voluntary response sample is if we deal with going to people where we are self-selecting a sample. And an example of that, you should read on your own the example in the book about having children. Very interesting example, and I'm not going to go through it on the video because you can read it on your own. But the key thing is, if we allow people to self-select, we are going to get strong opinions of people instead of good representative data. For instance, if you have something that is a call-in poll or some type of an online poll where people are going to respond onto an online survey, you're normally going to get people that have very strong opinions are going to be responding to the either phone poll or to the online poll rather than getting a good representative sample. So anytime you have people self-selecting, that's called a voluntary response sample, and it tends to end up having a bias and not be representative of the whole population. Now, another way that we often collect data is we use convenience sampling, or we go to the people who are easy to reach. You might do sampling in your pride classes so that you don't have to run around and do something with an unbiased sampling technique. So convenience sampling is picking people, asking questions of people who say are your friends. And when you do that, you automatically have inserted bias into your data selection. Systematic sampling is a sampling technique in which you start at a certain location and pick every kth element. For instance, let's say I wanted to get a sample of people from our school, and say there are 1,000 people in the school. And so I get a list in alphabetical order of all the students, and then I decide to pick every 10th person on the list to be in my sample. That's called systematic sampling, and that still comes to it with some bias. And why would that be biased? Let's say we had brother and sister who are right next to each other in that alphabetized list. And because of the way we would be systematically sampling, if one sibling were picked, the other sibling automatically would not be picked because it would not be the next 10th person, say, in the list. It would be right next to that person. So any type of bias in which everybody is not equally likely to be chosen has some type of a bias factor to it that can cause our data not to be very representative. So quite often we'll see this acronym, a simple random sample, is ultimately what we would like to do. And that's where each person or each entity that we're dealing with has an equal chance of being selected, like picking a name out of a hat, like having a computer randomly pick somebody, like using random digits, which you used in a previous math class, and we'll look at an example of using the random digit table. So you will want to grab your book. Now, another type of sampling is cluster sampling, and that's where we take a large group and divide them into sections. say we were dealing with the state of Michigan, and in the state of Michigan, maybe we divide them up by counties. Then we randomly select some of the counties, and then we would sample all the people within that county. So, say you had all the counties of Michigan representative and you randomly picked two of them, and then you sample everybody in that county on a specific issue. That would be called a cluster sampling. And again, it's not as good as a simple random sample. Could be some bias just associated with picking that cluster. Multi-stage sampling is where we keep honing down in stages. Say we have, as I gave in the other example, we have all the counties in the in Michigan, and we pick some of those counties, and then maybe we pick certain townships within those counties, and then maybe we pick a random sample of people from those townships. So it's a way of having stages of trying to whittle down who you're going to sample. And again, all these have ways of creating some bias. So the simple random sample for us is the best. Now, how can we choose a simple random sample? Well, first of all, we would have all the people in the population or all the individuals in the population maybe assigned a specific number. And then we could randomly pull from a random number table people or numbers that are representative of those, and each person would be equally likely to be chosen. Now, I gave an example on the back. So let's say we have a firm wants to understand the attitudes of its minority managers toward its system for assessing management performances, which we want to basically look at how are we going to pick some sample. And so the firm has a list of 28 minority managers. So that's the population of managers who are there. And now we would want to use the random number table to help us choose 6. Now, one way to get a simple random sample is literally write each person's name on a piece of paper, each piece of paper being the same size, fold them exactly the same way, or don't fold them at all, put them into a hat, mix them up, and pull out 6. Each person would be equally likely to be chosen in that case. However, we can also use our random number table. Now, we would start out, we'd have to assign each person a two-digit number. The first person could be 00, first person could be 01, first person could be 03. That would be arbitrary for us. Probably be easiest to assign the first person in the list 01, second person 02, etc., all the way up to the 28th person being 28. Then, as I have up here, if I want to use a particular line, basically we usually just kind of close our eyes and just point at a line kind of at, quote, random. But then we would choose the first 6 numbers who are viable numbers would be the ones who would be used. So for instance, hopefully this focuses okay. If I went to line 139 in my book, 139, my first 2-digit number would be 55. That's not a person, so I can't use that. So I go to my next two, 58, can't use that person. Go to the next two, 89. That's not a person. I only have 01 through 28. Next person's 94. Next person's 04. So my first person that I would choose would be the 4th person on the list, 04. Now, if I come to 04 again, I would discount that person and not choose them twice. And likewise, the next person, 70, that's a non-person. 70, non-person. 84, non-person. Next one would be 10. And I would continue to go on that line until I have selected all 6 different people. Once I get done with line 139, I go to line 140. And again, typically what we do, this exercise said to use specifically line 139, but normally I would just close my eyes and kind of point to a number and then start at the beginning of that row. So here's a nice organized list of some random numbers that have been generated by a computer. Now, what's a stratified random sample? A stratified random sample is we first divide a population into smaller groups of individuals, and we call those strata, and then we choose a separate simple random sample from each of the strata, and then we combine them together to be our full sample. For instance, we look at how could I use stratification at a high school in conducting a survey. Say I wanted to survey a number of people. Say I wanted to get 40 people in our school to get some information and to try to predict maybe some behavior. And maybe instead of just taking a simple random sample of the 1,000 people in the high school, I'd say, hey, I want to get 10 sophomores, 10 freshmen, 10 juniors, 10 seniors. So I could stratify the people first, divide them up into 4 groups by class, and then get my list of, say, 250 freshmen and randomly use a simple random sample from that freshman class, and then get a simple random sample of 10 from my junior class, senior class, sophomore class, etc. Now, we may also do something that we do some stratification by gender. We could say, well, I'm going to divide up males and females and say I want, again, a sample of 40 people.